Okay, let's have some fun with the magic LEDs. Here I have 8 LEDs. They're just generic red LEDs. And then I have the anode side all daisy chained together, so they're all in common, connected to pin 2 of the Arduino. And then pins 3 through 10 connect to the cathode side of each individual LED. I really should be using resistors on this side, but this works okay, but I wouldn't recommend it for long-term use. Then I have a little pen light here, actually keychain light, I guess. And watch what happens when I hover the keychain light over the first LED here and I press it. Notice the LED comes on. I go for the second LED. Now it's on too. Just try the last one. Now it's on. Now they're going to stay on there hopefully as long as I want them to, except I can come back and illuminate the first one again and turn it off, and do the second one again, and the last one again. Or I can pick the middle one, its neighbor, and so forth. And turn them on, I can turn them off, just by shining a light on the LED. So how could this possibly work? The science behind using LEDs as light sensors is fairly well spelled out in this article from 2016 by SparkFun. It describes how in a normal connection of an LED you produce light, but that if you reverse that connection you can actually charge up the junctions like a capacitor, and then they'll hold that charge in proportion to whether they're illuminated or not. So you get a short discharge time from the charge to the ground. If it's being illuminated with light, you get a longer discharge time with less light. So by measuring this discharge time, we can tell whether or not there's a light source currently illuminating the LED or not. Here's some code you can use to measure the discharge time of the photodiode and determine the delay you need to use to distinguish between whether the photodiode is being illuminated or not. The code from line 12 down to line 16 is used to charge the photodiode by selecting the cathode as an output and then applying a high to it. Then the code from line 18 down to 24 flips the cathode line as an input and then sits in a loop until it detects that the line has gone low, during which time it's measuring the intervals in milliseconds. Then finally it prints out the value to the screen. Okay, let's demonstrate how the code I just talked about works. So I have the code visible on the right and I have the little test setup visible on the left. And I'm only going to be using the first LED here. That's the only one that's connected to the code. And notice that I'm going to start up the serial monitor and it's going to start printing out a stream of numbers that show me the time delay for how long it takes for the photodiode to discharge from a high state to a low state. And it's going to vary around based on ambient light where my hand position is, but if I move my hand over the LED, you can see the timing gets very long. If I pull my hand back, the timing gets very short, or shorter. Now if I illuminate it with a little pen light, it's going to drop down quite low. So that's basically how we tell the difference. Now the timing delay is going to depend upon the particular photodiode that you're using. So you'll want to use this code to figure out a value that's sort of halfway between the normal ambient light conditions and the condition where you've got the LED illuminated with the pen light. And then plug that value into the code. I think I used a value of about 20. I could have gone a little bit higher, I think, but you can test it out and you can experiment with that. Okay, let's put all the pieces together now with a program that simulates a magical candle you can switch on and off by using a keychain light. The first step, as before, is to charge the photodiode, then switch the pin connector to the cathode to input mode, then wait for the delay time that we discovered previously using the timing program. Then the next section of code watches for the LED to stay illuminated for 20 successive cycles. If so, it flips the state of state, which indicates whether the LED is on or off. And then finally, in the last stage, if state is true, it switches the connections around again so it can illuminate the LED for a number of cycles, in this case 3 milliseconds, and then it begins the sequence all over again. I'll show you one final demo to give you an idea of what else you might be able to do with this technique. Watch as I scan the pin light across the LEDs from left to right, and then from right to left. or some different pattern. If you want to learn how this demo works, please see my webpage that contains all the code you can download. There's the three programs you've seen so far, plus this particular demo, are all available there in the form of zip files you can use with the Arduino IDE. And if you like this video, please give it a big thumbs up and please subscribe. I'm trying to get my channel started, and every little bit helps. So thank you.